Okay, let's jump right into this explainer. Today, we're zeroing in on Chapter 27 of our source material, Diagnosing Your Observability Investment. We're going to evaluate your organization's observability health, and honestly, make sure you aren't just paying for an incredibly expensive illusion. You probably know the exact scenario I'm talking about, right? You're shelling out absolute top-tier premium enterprise software rates for a toolset that promises total visibility. But then, a massive Severity 1 outage strikes on a Friday afternoon, and your team is still spending 4 frantic, stressful hours just trying to track down a simple memory leak. If you've been feeling that growing pressure from leadership or from finance to cut your observability costs, you are definitely not alone. It's rarely a fun conversation when the people holding the purse strings start demanding justifications, but you know what? That cost pressure can actually be a really good thing. It forces us to step back and ask the hard questions about what we're actually getting for our money. So we're going to walk through a comprehensive diagnostic of your current investments to see if your strategy is genuinely working or if it's time for a major treatment plan.
So, let's start with a rather shocking number. According to Gartner, the cost of observability has been skyrocketing by at least 40% year over year for the past 15 years straight. Think about that for a second. 40%. That is not just a temporary little spike, that's a compounding decade-and-a-half-long explosion in costs. And to be fair, there are very tangible technical reasons for this runaway freight train. I mean, we've completely changed how we build systems. We shifted away from those massive monolithic applications just sitting on a few servers, right? Now we're building highly distributed ephemeral microservices architectures running on Kubernetes. And the catch is, every single time a container spins up or tears down, every time a request jumps across a network boundary, it generates telemetry. We are producing logs, metrics, and distributed traces at a volume that literally was unimaginable 15 years ago. And because that data volume scales right alongside the complexity of your system, the cost to store, index, and query all of that data has naturally gone right through the roof. Honestly, it's no wonder finance departments are starting to raise their eyebrows at these bills.
Because of that cost explosion, observability is now the second largest software line item in R&D organizations. The only thing more expensive is the cloud spend itself. It's actively eating up a massive 10 to 25% of the typical infrastructure bill. To put that into perspective, we really have to pause and consider the opportunity cost here. If an organization is spending, say, $10 million on their cloud infrastructure, they could be spending up to $2.5 million simply to watch that infrastructure run. That's dozens of engineering salaries. That could be an entire product division completely consumed by an operational tool set. When a single category of tools is chewing up a quarter of your entire infrastructure budget, it fundamentally stops being just a technical decision, you know? It becomes a major business liability if it isn't delivering undeniable, proportional value straight to your bottom line.
That brings us to Section 1, the Observability Cost Crisis. Let's dig in.
Let's take the patient's vitals here and explore why so many tech leaders are feeling this intense budget anxiety, yet completely failing to see the strategic returns. The core issue driving this anxiety is a massive, fundamental mismatch. Organizations are paying premium, modern observability prices, but they're only getting basic, reactive monitoring outcomes in return. So what does that actually mean in practice? Well, basic monitoring is when you're relying on pre-computed dashboards to tell you, say, if a server's CPU is spiking or if a specific database is up or down. It's built entirely for known unknowns. But true observability, that is a highly strategic capability designed for unknown unknowns. It's what lets you fluidly query high cardinality data to figure out exactly why a tiny subset of users, maybe on an outdated iOS version in a specific time zone, are suddenly experiencing massive latency. The problem is, you're essentially paying for observability as if it were that strategic, high-powered capability, but you're operating it like a legacy cost center, using it just to monitor whether the lights on the dashboard are green or red. If you aren't getting the returns you feel you should based on what you're spending, well, your instincts are spot on. You've got a massive expectation mismatch.
Moving right along, let's head into Section 2, Escaping the Firefighting Trap.
We really need to look at the reality of your day-to-day operations and examine how your engineering team actually responds when things inevitably break in production. Think about how your team reacts. I love this analogy. If your goalie is making 50 saves a game, your defense is not working. Operations and incident response, they should be your goalie. They're the absolute last line of defense when everything else in your software delivery lifecycle fails. But if alerts and escalations are the only way you're learning about system degradation, your frontline defense has fundamentally failed. If your teams are constantly huddled in these massive 20-person Zoom war rooms, constantly reacting to arbitrary threshold alerts, just fighting fires to keep the system afloat, your observability isn't giving you proactive visibility. Actually, scratch that. It's not visibility at all. It's just a remarkably expensive fire alarm.
you start suffering from alert fatigue, where engineers literally just start ignoring the pager because it goes off so much, and that is the ultimate symptom of a totally broken defensive strategy.
So you need to ask yourself this right now. What percentage of your investment is going toward fighting fires versus preventing them? And this brings us to a massively counterintuitive trap. When finance demands spending cuts, the knee-jerk reaction by engineering leadership is often to just ingest less data. They start aggressive sampling, dropping logs, maybe turning off tracing for certain services just to shave a few grand off the monthly bill. But here's the catch. Cutting data creates immediate blind spots. Let's say you drop telemetry for a legacy payment service to save a few bucks. A week later, a deployment causes a really subtle configuration error in that exact service. Because you created that blind spot, an outage that should have taken 15 minutes to identify and roll back now takes 12 painful hours of guesswork. Those blind spots directly lead to higher operational risk, catastrophic downtime, and ultimately higher long-term costs that completely dwarf the pennies you saved by dropping the telemetry in the first place.
All right, Section 3, an investment posture mismatch. Let's see how you're approaching this spend.
There is a stark contrast in governance models when it comes to managing this kind of tooling. When you optimize strictly to cut costs, you ingest less data and you create those dangerous blind spots we just unpacked. In that scenario, you're treating observability purely as a cost center, as just another bill to be minimized. But true observability, especially when you tie it to developer learning loops, requires a completely different mindset. It requires a governance model of strategic investment. Strategic investments are completely different beasts. They optimize for capability growth, for learning speed, and for competitive advantage. Instead of asking, hey, how can we make this tool 5% cheaper this month, a strategic posture asks, how can we leverage this tool to empower our developers to ship code twice as fast without breaking production? They're evaluated by what they produce, like engineering velocity and systemic resilience, not just by what they cost. And frankly, framing this as a strategic investment that builds a competitive moat, that's much easier to defend at a boardroom when the budget is tight.
You have to evaluate your current posture by looking closely at your team's actual capabilities. Ask yourself, are you moving the needle on the business metrics that actually matter to your bottom line, or are you just saving pennies while actively increasing your systemic risk? Let's talk about what debugging novel problems instantly actually looks like in the real world. Imagine a VIP enterprise customer submits an urgent support ticket saying they can't check out. In a poorly invested organization, engineers literally have to push new code just to add custom logging, redeploy the whole service, and then just wait around for the error to happen again to see what went wrong. But in an organization with a strategic observability posture, an engineer can instantly query the high cardinality trace data, isolate that specific customer's user ID, trace the entire distributed request across 20 different microservices, and find the failing database query in maybe 3 minutes. If your observability investment isn't generating these kinds of new, powerful capabilities, you are completely misaligned.
Let's shift gears to Section 4, activities versus real learning.
Without the proper attribution and validation that true observability provides, well-intentioned productivity practices mutate into incredibly painful failure nodes. Look, we all want to invest in modern practices, but let's dive deeply into what actually happens when your feedback loops are long, laggy, and lossy. Take chaos engineering, for example. The whole goal there is to build resilience by intentionally injecting failure into your systems, right? But if you lack the proper observability to instantly track the blast radius of that injected failure, chaos engineering isn't a learning tool anymore. It just becomes pure disruption that accidentally takes your actual users offline. Then you have feature flags. Brilliant concept for decoupling deployment from release. But if you can't validate how turning on a specific feature flag impacts downstream database latency or error rates in real time, those flags just evolve into an unmanageable web of technical debt and overlapping complexity. And what about progressive delivery, like canary releases? The whole point is to slowly roll out code and automatically roll it back if something looks wrong. But without precise, instant detection from your observability tooling to trigger that rollback, a canary release just turns into a significantly slower deployment pipeline where your developers are just sitting around nervously watching static dashboards.
The reality is, you don't capture the value of your productivity investments until your organization actually learns something from them. For every modern practice you've invested in, you absolutely must be able to explicitly identify the feedback mechanism that turns that activity into real learning. Think back to that feature flag example we just talked about. If a developer flips a flag to route, say, 10% of traffic to a new recommendation algorithm, the learning only happens if the observability system can instantly answer the question, did the conversion rate drop for that 10%? If you can't see the exact impact of flipping that flag, or if you don't know the precise blast radius of a chaos experiment before it hits the customer, well, you aren't learning.
You're just doing engineering activities in the dark and crossing your fingers.
Okay, it's time for the prognosis. Section 5, evaluating your investment success.
Let's look really closely at your operational loops to evaluate if your strategy is actually working to cure the symptoms. These loops are downstream and highly time-sensitive. If your investment here is working, you should be seeing clear, quantitative evidence. First off, the mean time it takes to identify known causes should be noticeably decreasing. Second, your alert quality absolutely must be improving. I can't stress enough how massive fewer false positives is. If your on-call engineers are getting woken up at 3 a.m. for a CPU spike that automatically resolves itself by 3:05 a.m., they are going to burn out, and they are going to quit. Good observability creates a high signal-to-noise ratio. Third, you should see a noticeable, sustained drop in incident escalation rates. This means your Tier 1 frontline responders actually have the context and the trace data they need to fix things themselves without having to wake up the senior architects. And overall, your mean time to recovery must be getting faster. If you're spending millions and these specific operational metrics are flatlined, your investment is failing.
Now, success looks a bit different for developer learning loops, but it is just as vital. Can your engineers answer completely novel questions about production without having to write new code or wait hours for new log indexes to build? Here's another massive indicator. Your deployment frequency should be going up while your batch sizes shrink. Why does observability cause this? Well, because when developers have high-fidelity, real-time visibility, they have the confidence to push microdeployments. They know for a fact that if they break something, they'll see it in seconds and can revert it immediately. Furthermore, you should be seeing more engineers debugging independently. You shouldn't have to rely on the exact same 3 hero engineers who have all the system's weird quirks memorized every time something goes down. The time it takes from forming a hypothesis, like, I think this query is causing the deadlock, to actually validating it in production should shrink from days to minutes. And perhaps the absolute ultimate metric of success, the number of bugs found internally by your own team goes up, while customer support reports and angry Twitter complaints go drastically down.
All right, let's write out the treatment plan. Section 6, optimizing your strategy.
Here is your tangible roadmap for proactively managing this massive investment going forward. Step 1. You must identify the point of diminishing returns. Yes, meticulously track the cost of your telemetry ingestion, but do so while asking where targeted investments will unlock disproportionate business value. You want to cap your spending on low-value data where the returns start to fade, and then ruthlessly reallocate that budget to the high cardinality data that actually speeds up your recovery times. Step 2. Quantify your gaps in visibility using comprehensive impact statements. Don't just look at the immediate revenue loss during an e-commerce checkout outage. You have to calculate the hidden compounding costs. How much are you paying in strict service level agreement, or SLA, penalties to enterprise clients? What is the actual dollar value of 50 engineers sitting entirely idle for 6 hours during a P1 incident? What is the cost of reputational damage and customer churn caused by your inability to quickly connect cause and effect? And step 3, align your goals and your spend directly to business outcomes. Choose your workflows and your tool configurations based entirely on the specific feedback loops your organization actually needs to strengthen.
To wrap up this explainer, I want to leave you with one final, critical thought to help you audit your team's entire approach. When you look at that massive 40% year-over-year growing line item on your infrastructure bill, what are you actually buying? Are you buying true understanding, empowering your developers to move fast, debug fearlessly, and learn continuously from real production traffic? Or are you just paying the ransom on an opaque, overly complex system, throwing millions of dollars at static dashboards that stay perfectly green, while the underlying mysteries of your system simply become engineering folklore? The choice and the strategic investment is ultimately yours to make.